Hello everyone, welcome to the second part of solving OPSC PGT Physics paper 2025. So in this series we have completed till question number 10 and today we are going to start from question number 11. This question is from quantum mechanics. As you all can see, this is asked about computational value of the ladder operators. So let me write it first. L plus L minus commutation bracket. Okay. We have to know what is L plus. L plus could be written as Lx plus I Ly. Okay. Similarly, L minus, these are the ladder operator of angular momentum. Okay. And L minus can be written as Lx minus I Ly. Okay. And if I put it in the commutation, so you will get Lx plus I Ly comma Lx minus I Ly. You now open the brackets, so you'll get Lx plus ILy into Lx minus ILy minus Lx minus ILy, Lx plus ILy. These are operators, always remember that. So this will become Lx square plus minus, sorry, so this will become minus ILx Ly. Similarly, this will become plus ILy Lx, and this will become uh, plus I minus I. So this minus I square, so I square is plus 1, so it will become plus Ly square. Similarly, minus Lx square, and this will become minus I Lx Ly, and this will become plus, so plus iota Ly Lx. Similarly, this will become minus Ly square. You can see I have plus Lx square and minus Lx square. I can cancel it, and plus Ly square minus Ly square. So we are getting, that implies, so this is minus ILx Ly and minus ILx Ly. So minus 2ILx Ly, Lx Ly. Similarly, plus 2I Ly Lx. Now you can see I can take minus 2I outside, so I am getting Lx Ly minus Ly Lx. And this term, this bracketed term, if you remember, we have seen this bracketed term as the commutation of, you all know that Lx and Ly. I can write it. And you know this result is what? Minus 2I. This is I h cross Lj, isn't it? Yes. And I, so it will become I square is minus 1. So 2 h cross Lz is your final answer. 2h cross Lz is your final answer. Okay. C in the option, I have C. Option C is the correct answer for us. Then question number 12. It is asking about the expectation value of the kinetic energy for hydrogen atom in ground state. This is also a question from quantum mechanics. Okay. We have been asked the hydrogen atom in ground state to find the expectation value of kinetic energy. First of all, we need to know what is the total energy in the ground state. Total energy in ground state of hydrogen atom. You all know that, I guess. So the total energy in the ground state of hydrogen atom is nothing but minus E square upon 2A naught. You have to remember this. The ground state energy of hydrogen atom. Okay. From the virial theorem, we all know that kinetic energy, expectation value of kinetic energy is nothing but equal to the expectation value of potential energy, and there is a one negative sign, divided by 2. So you know, in the hydrogen atom, where we generally consider the Coulomb potential. So the Coulomb potential is nothing but, your Coulomb potential can be written as E square upon R, and here R is nothing but A naught. Okay, so I can write minus E square upon A naught. So my kinetic energy will become minus E square upon A naught divided by 2. Okay, so it will become minus E square upon 2A naught. Is it clear to you? And one more thing we need to consider, there is one negative sign here, and here is also one negative sign. So it has become plus. Okay. So the answer is plus e square upon 2a0. See, in the options, we have both positive and negative sign. You have to consider about the sign. Okay. So the correct answer here is option C, a square upon 2a0. The next question, see, this question is directly asked from the book. Okay, this is an identity, a dot sigma comma b dot sigma commutation. Okay, this is also a question from quantum mechanics. So uh, I can prove this identity for you. So you just have to do nothing, but you try it on yourself. I am giving you the hints. Okay, if you do not able to do this, you can comment in the video. So I will, in the next video I will do it. So a1, you can write it as a1 I cap, a2 j cap plus a3 k cap, and b vector you can write it b1 I cap, b2 j cap, b3 k cap. Similarly, you know sigma vector can be written as sigma x I cap, sigma y j cap, and sigma z k cap. Okay, you just do the dot product and then you open the commutation bracket so that you can get the simplified form, and from there you can take the common, you can rearrange the terms, and you will get this option as your correct answer. You try it on yourself. If you are unable to do it, then comment down below so that I could make this in the next video. Okay, next. Yes, this is an important, very, very important question, I guess. So this is also from quantum mechanics, and it is something related to your projection, that is the direction of the particle, or how the particle is about the spin of particle, we can say. Okay, and what is the rotation about the x-axis? It is given 60 degree about the x-axis, it is rotated. Okay, and the system of spin particles is being given, and one more thing is given to be in the eigenstate of sigma z. Okay, the system is in the eigenstate of sigma z with eigenvalue of plus 1. So let me denote the eigenstate as psi. Okay, and for sigma z I am denoting as psi z. Is it clear to all of you? I guess yes, it is clear. And it has an eigenvalue of plus 1, so I am denoting it as plus. And then what happens? It is being rotated about the x-axis by angle 60 degrees. So theta here is 60 degrees. You have to know what is the rotation operator here. So the new state can be written as, remember this formula, e to the power minus I theta, and about which axis it is rotated, you have to write that Pauli matrices. So here x-axis, so I will write sigma x upon 2. Okay, and the previous state, I have the previous state as psi z, so I will write it here. Okay, and you know this thing could be expanded as e to the power minus I theta sigma x by 2 can be expanded as your cos theta by 2, and your here is the identity matrix, then minus I sine theta by 2, we have sigma x. Okay, I think this is clear to you. Then we have nothing, but you have to just solve it. You have to just put the value of theta here. Okay, theta is 60 degree, so you'll get 30 degree from here. So cos 30, you will put the value, you have to put the values. So by putting the values, you will get the answer as option C. I'm not solving it in details because it will take more time. So I want to stick to the certain time limit so that the video will not be long. If you want the detailed solution, I could make it in the next part. If you want, I am just giving you the hint. I think this much of hint you can do this problem. I have that belief. Okay. In the next question, see, this is also from quantum mechanics. Today, the many questions that I have solved here. So all the questions are from quantum mechanics. Okay. So see, We have given the root mean squared momentum of a particle in the ground state of a one-dimensional harmonic oscillator. First of all, you have to mark this sentence, harmonic oscillator. It is given as harmonic oscillator. So the system is harmonic oscillator, and it is asked, it is given that the root mean squared momentum value. So how to write the root mean squared? This is important. The momentum, so momentum is P, and write it from the inverse side. So I will just square it, then mean, then root. Okay, this value is given as the ground state of is P0, and we have been asked to find it. It is ground state, so I am writing it 0 here for ground state. It is asked to find the root mean square value for momentum in the fast excited state. Let me denote it as P1. Okay, so how do we solve this? It is asked then its root mean squared momentum in the fast excited state. So let me tell you about how to find out the root mean squared value. So P square root is nothing but for harmonic oscillator, we can write it as half n plus half m h cross omega. Okay, this derivation you could see in the N. Jetli book. Okay, it is given beautifully in that book, and you can also see Griffith for this. And n is for ground state n is 0, for fast excited n is 1. We can put that. So P1 upon P0, what is this? The ratio we will find out. So the first is half, n is 1, so half m h cross omega upon half, and n is 0 here, plus half m h cross omega. So cancelling the terms, and we are getting 3 by 2 upon 1 by 2. 1 by 2, 1 by 2 getting cancelled, we are getting 3. So P1 is nothing but 3 P0. Okay, is it clear to all of you? So this is 3 P0. But one more thing we need to consider, these I have denoted it as P1, but the formula here is P square, only the mean value of P square is this much. So I have written it wrong as the, let me correct it first. Okay, now this is correct. P square is this much. So I got this value as 3, but I have to square root it. If I do the square root, then you will get P1 is root 3 P0. Sorry for the mistake. I have written it as root. So that was wrong. So yes, you got the answer as option C. Okay. The next question is, let me just put the charge. Okay. The next question is 16 number question. This is also from quantum mechanics. Let's see what it is given. It is given we have two normalized states, 0 and 1. 0 and 1. We have two normalized states. And fast excited state of one-dimensional harmonic oscillator. This is the ground state and this is the fast excited state. The uncertainty delta P is asked. We know that delta P can be written as P square mean minus P mean square. Okay, we have given harmonic oscillator, one-dimensional harmonic oscillator, as it is a physical system, so we could write the P average is 0. So only we have delta P as P square mean root over. We have to find out what is P square. This we have given the state as half, 0 plus 1. We have to find out in this state only. So let me write what will be P square if we operate this, the expectation value. We need to find out the expectation value. So 1 by 2, 1, so there will be another 1 by 2, so it will be 1 by 4, and we have 0. Okay, and P square, then I have 1 plus 0 P square, 0 plus 1 P square, 0 plus 1 P square, 1. Okay, these are the 4 terms you will get when you operate, when you need to find out the expectation value. You see the terms 0, p square 0 and 1 p square 1. What it will be? This is in the ground state, this is in the fast excited state. So this will become half mh cross omega. From this formula you can get it. This formula. Okay. And then we have in the excited state we have 3 by 2 mh cross omega. Okay. And this term 0 p square and 1 expectation value, you could get it 0, and this term will also vanishes. So I got 1 by 4 half mh cross omega plus 3 by 2 mh cross omega, and from here you can take half outside, or you could just add it. So 2 mh cross omega by getting cancelled, so 1 by 2 mh cross omega is the answer we are getting. So delta p will become the root over of this term, so half mh cross omega. You see, carefully see the options. Okay, in hurry you can make the mistake this, but b is not the answer because 1 by 2 is outside the root. So this option C is the correct answer here. The next question is on the perturbation theory. In order to do this, I could give you the hint. This is a direct question from Griffith. You can see the Griffith question, and it is also asked in previous year's CSR net. Okay. The expectation value you have to find out only. The first order energy correction. So this is psi 0 ground state is given. So H dash is the perturbed Hamiltonian and psi 0. You have to just find out this. Okay, in order to find out, you have to just integrate it. Psi 0 dash, you have the limit from 0 to phi. So do this. And H dash, you have to just put it the value psi 0. Then you put psi 0 for, you know, infinite. For infinite square L we have 2 upon pi. For ground state we have sine pi x, and L is here pi. So this is the wave function for ground state. So just put it here. So I'll get, if you just, let me write it. If you just 2 upon pi root, so 2 upon pi will get outside, and here we will get the perturbed Hamiltonian bx, and we have sine square pi x upon pi dx. Okay, this is the integration we need to do. So if you solve this integration, you could get the answer. Okay, I am not telling you the correct answer because you need to do the integration by row. I am not going to spoon feed you. Okay, if you don't able to do this integration, then tell me. You have to just, I am giving you one more hint also here. You just need to do the partial integration. Okay, do the partial integration, you could get the answer. Okay, this is a direct question. And here this is the commutation x square p square is asked. I think you could have able to do this question also. This is also from quantum mechanics. I am not going into detail. Okay, this is the direct question. You could get this. And the question number 19c, we have alpha and sin x. The commutation is asked. Okay, so alpha is x d upon dx and sin x. Whenever this type of question is asked, you just operate on some wave function. I am operating it on the psi, wave function psi. So you will get x plus d upon dx sin x psi minus sin x x plus d upon dx psi. So we will get x plus, if we write it directly, so we will get x sin x psi plus, if you do the derivative, cos x psi plus sin x d psi upon dx minus sin x x psi minus sin x d psi upon dx. Okay, you can see this term is getting cancelled, this term is also getting cancelled, so we'll get cos x psi. So by comparing this with this, the final answer is plus cos x. So option number B is the correct answer. I hope till this you all are clear with the questions asked. These are all the questions are from quantum mechanics. I think you all enjoy this session. If you have any doubt or you are unable to solve the questions from the hint I have given to you, you just comment down below. I will solve it for you. Okay, I hope you all enjoying this. If you enjoy this, so if you are benefited with this from this, you could share with your friends, and you could subscribe to the channel, and you could join in the Telegram channel given the link below. Okay, thank you very much.